But tonight it's all about the Northern Lights, and we are very lucky to have Melissa Kaelin with us. Melissa's day job is Manager of Marketing and Communications at the University of Michigan Department of Climate and Space. But at night, she chases the Northern Lights, something she's been doing for over 10 years. She's a co-founder of the Aurora Summit held in Wisconsin in November, and now in its 6th year. And she's the founder of the Michigan Aurora Chasers, established in January 2021, and now over 73,000 members. She recently spoke at both the Headlands and the Keweenaw International Dark Sky Parks. She's published fiction, poetry, and short stories about the mythology of the Milky Way and the Northern Lights. And tonight she'll be selling her latest book, Below the 45th Parallel, The Beginner's Guide to Chasing the Aurora in the Great Lakes region, which we will have for sale and signing right after her presentation. So now please welcome the woman who never sleeps, Melissa Kaelin.
Thank you. Thank you. All right. Forgot my remote. Welcome. It's good to see you all here. I am Melissa Kaelin, as you know. Running the Michigan Aurora Chasers is a labor of love. I absolutely love it. It does take a lot of time, especially at night. But there's nothing more rewarding than helping people realize that dream of seeing the Northern Lights for the first time. In fact, for some people, it's downright life-changing. So how many of you in here have seen the Northern Lights? Show of hands. All right, we've got some Northern Lights viewers in here. How many of you have seen the Northern Lights in Michigan? Oh. All right, good show of hands. That's great. How many of you have seen the Northern Lights in a beautiful color photograph? I'm guessing there's a lot of, there we go, there's everybody. Now, how many of you have seen the Northern Lights with your own eyes in color? See, a few hands went down. All right. So tonight we're going to help you determine how to find the Northern Lights and what it takes to do it at lower latitudes. You heard a little bit about me already. I live right here in Ann Arbor. I'm very excited to be here. I just moved here last year to work in the University of Michigan Department of Climate and Space, where I get to interview some of the world's leading researchers about the solar wind, which creates the aurora borealis, and some of the spacecraft and NASA missions that the university is working with agencies to send up to study outer space in our night skies. So it's really exciting. But that's just what I do for work. In my free time, I love writing. I started as a writer and a social media guru, and I've really become sort of a community leader, I guess. I love bringing groups of people together to celebrate this rare natural phenomenon. How to catch the Northern Lights. All right, a lot of you may know some of this stuff, but if you have any questions as the presentation goes on, I'm happy to stop and answer and sort of expand upon your knowledge. So it takes a lot of things to see the Northern Lights at our latitude in Michigan. We not only need the right conditions on Earth, but we need the right conditions in outer space. So I like to tell people that if you're going to see the Northern Lights, well, if you're going to see it during a very strong aurora display, you actually might have a fairly easy time. You actually might be able to walk outside, look in your backyard toward the northern horizon or up into the sky and see the Northern Lights. You might see a flowing and moving. You might see pillars shooting up into the air. You might see formations that are not shaped anything like the clouds, or you might even see color. And with some of the strong storms that we've been getting lately, you might even see some of those Northern Lights within city limits, within light pollution. But that's not always the case. If you want to see more aurora, because I saw a lot of people raise their hands that they've seen it, you have to keep a lot of things in mind. Aurora is a lot more subtle than most people realize. In fact, I talked to a lot of aurora chasers who the first time they saw the Northern Lights, they thought it was a cloud. If you're anywhere near a city or some of that light pollution, some of those street lamps that can really sort of dim your night vision, and you look out onto the northern horizon, your eyes are going to be distracted by the light, and you're probably not going to pick up the colors or even some of the formations of the aurora out there far away. But if you let your eyes adjust to the dark, look a little closer, really let your night vision adjust for a good 5 minutes. Standing there, don't look at your phone, don't disrupt your night vision, just focus on the darkness and let the darkness in. Then all of a sudden your eyes start picking up more light and you can see the northern lights. That's why a lot of people, when they see this faint white or silver on the horizon, they don't realize that's actually the aurora. It's just we're so far south of where it enters the Earth's atmosphere. It's very hard to see from here. So these things are going to help you find the northern lights even when the conditions are low. You need starry nights. And I say that because if you're looking out on the horizon and you're not seeing stars, you have to be doubtful, because the northern lights are sort of transparent. It's like a veil of color or light coming down from the sky. And that means you can actually see pinpoint stars right through the colors, right through the lights, right through the formations. In fact, if you look really closely at a lot of those photographs, you're going to see that there are stars in them too, through the entire photograph on a clear night, with the northern lights right there on top of it. If you're not seeing stars, you might get fooled. You might instead be looking at light pollution, which looks an awful lot like pretty lights in the sky, depending on your perspective, or you might be looking at cloud cover. The way to tell the difference between northern lights coming down from high altitudes into Earth's atmosphere and light pollution coming up from the ground and lighting clouds is that, if you're seeing clouds, you will always see the light kind of on the bottom of your photo or of your view. The northern lights should appear above the clouds or beyond the clouds because they happen at very high altitudes. And like I said, they're transparent. You can see the stars right through them. The darker your skies are, the better it's going to be for northern lights. I think a lot of people know this, but I think what a lot of people don't know is that if you find a truly dark location that's far away from city lights, and you can look at light pollution maps to help you find these locations, you're probably going to see the color where you otherwise wouldn't. I once saw the northern lights right above my home inside a huge metropolitan area, and I could not see any color at all, but I saw them moving and the dancing and the shapes and the formations. They were completely white though, because I was in the city. So starry nights, dark skies, moon phases is another big one. When we have a full moon, that's a lot of light coming into the sky. And so that can actually wash out the color of the northern lights and make it harder to see. Now, you can still catch the northern lights on camera even under a full moon, but it's going to be really hard for your eyes to pick up that light, and especially that color in the dark. You can go out and chase aurora anytime, even during a full moon. But if you really want to find those colors, try to go during a new moon or when the phase of the moon is relatively low. We like to wait until about halfway through the month to encourage people to really spend all night under the sky, because they've got about half moonlight and it's not as bright. There are other obstacles too, though. We had some Aurora Chasers in the Michigan Aurora Chasers group catch the northern lights last night and the night before, but it was really tricky for a lot of reasons. One of those reasons is we're now entering the summer months. Who's feeling the hot today? And that means that wildfires are a risk in Canada, sometimes in northern Michigan and in other parts of the country. Wildfire smoke is wispy and thick enough that it can actually obscure the view of the aurora so that you can't see the northern lights through the smoke. So last night it was really hard to see those aurora because of that wildfire smoke that's drifting down into the UP and northern Michigan from the wildfires up north. Another obstacle might be fog or mist. The northern lights can be so subtle in appearance. Sometimes people see them in a really fantastic, phenomenal, colorful display where you cannot mistake it. But if you're looking for northern lights all the time, and you also want to catch those subtle shows, even fog could block out the view. It's just there's too much precipitation in the air. These aurora are happening at an extremely high altitude, and that light can't filter through that fog or mist. In fact, I've heard some people have taken vacations to Alaska or Iceland, and they've been there an entire week but never seen the northern lights. I think one of the reasons that happens is because people often choose to stay right beside the ocean. But the ocean or any Great Lakes system will create so much weather and fog and mist that that's going to obscure your view of the night sky in some cases. I had the opportunity to go to Alaska last year to celebrate 10 years of leadership in the Aurora community. And one night we went to a beautiful lake to see a beautiful aurora. Were completely obscured from view and ended up driving to another location in the plains so that we could actually see the night sky without obstruction. A northern location, obviously, the further north you are, the better your view of the northern lights. There is also the southern lights, or the Aurora Australis, and that's even harder to catch. That filters in through the South Pole, while the northern lights filter in through the North Pole. The Aurora Australis mostly happen over the ocean. Another thing for those of you who haven't seen the northern lights, it's important to realize that you can't always see them, especially in Michigan, with your own eyes. You could walk outside, look toward the northern horizon, and not see a thing with your own eye. But if you hold up a camera or even a modern cell phone and take a photograph in the dark with your night settings, all of a sudden you're picking up beautiful northern lights and beautiful colors, and you didn't even know they were there. So if you're still trying to catch her for show, don't trust your eyes. Try to bring a camera or a phone to help you. And there's a reason for that. It's because humans are not nocturnal creatures. The rods and cones in our eyes were not designed to see well in the dark. Otherwise, we'd be driving around without headlights on our cars. We'd be just fine at night. But a camera can pick up all of the light and all of the color in the dark because it's not limited by human anatomy. It's a piece of technology that's designed to pick up that color and light. And on a long exposure, the camera can pick up much more light in 30 seconds than our eyes can process while we're standing there in the dark. So remember, you may be out on a night when the northern lights are active and you might not see them. They could still be there. We also need the right conditions in space. So I'm going to move forward a little bit as we talk about this because I have some graphs to kind of show you what this looks like, or graphics. The aurora is created by a process of the solar wind, which starts on the surface of our sun and then propels solar matter or solar plasma toward the Earth through outer space to form a process that creates the northern lights. In order for this to happen, in order for that solar wind to make it through Earth's magnetic field and into our atmosphere, we need all these components to align. We need the composition to be really strong. We want to see a high solar wind speed, a high solar wind density, and then we need the numbers of BT and BZ to cooperate along with a number of other factors. So we need all these data points to align. It also depends on the direction of the solar wind. A lot of people these days are using aurora forecasting apps to try to figure out when the northern lights are active. Well, if you want to use your app, you're going to have to dig in to understand what some of these things mean. The sun could throw some activity our way, but if it's not, if something happens and that solar activity gets directed, that solar wind gets directed away from Earth and off a different direction into outer space, all of a sudden we have nothing. In the Michigan Aurora Chasers, we also talk about that pesky BZ. And I'm going to make the joke, if you know, we'll talk about it. This has not been our friend this week. Otherwise, we would have had way more aurora. This is essentially the gatekeeper that decides, is the Earth going to get a light show tonight or not? So this is how it all plays out. The solar wind, as I said, starts on the surface of the sun. And then we can see flares and we can see sunspots and we can see coronal holes that have lots of different magnetic makeup and lots of different energy and charges going on. And if one of those things releases off the surface of the sun and heads in Earth's direction through outer space, it is creating the potential for northern lights, but it also needs to enter through the Earth's magnetic field, which is designed to sort of protect us from some of these impacts from outer space. And then that solar wind needs to filter into our atmosphere through the north and south poles and form the auroral oval. The stronger that solar wind is, the farther south, in our case, or north, in this case, the aurora will go. So in order to study this, there are magnetic fields involved. We use lots of satellites and spacecraft that are monitoring what's happening in outer space. And we're watching for these impacts to see, okay, did the sun have a solar flare come off the surface? And then did that solar flare create a CME? A CME happens, it's called a coronal mass ejection. And that happens when a flare releases from the sun and flies through outer space toward the Earth, completely separate of the sun now. A lot of times this energy, the sun has such a strong magnetic field that this energy will just get sucked right back in. So when we watch for those flares, we have to note, okay, did it get sucked back into the Earth's or the sun's corona, or did it release and fly off into space? So we monitor the sun, and you can see some of the different satellites and spacecraft that we use to do this, like SDO, the Solar Dynamics Observatory, or ACE, the Advanced Composition Explorer. You don't necessarily need to know all this, but there's a lot of science that goes into trying to predict the northern lights. We monitor what happens on the sun, and then we monitor what happens right outside of the Earth in those conditions of the magnetic field. And then we watch all of the data and watch for those impacts. If it doesn't make impact, we get the dreaded dud. No northern lights. So I can answer questions about this as we go, but what's happening here is our magnetic field, which forms around the Earth and then goes out in front of the Earth, between the Earth and the sun, and also has this magneto tail. Our magnetosphere is built to protect us from these impacts and to protect us from other things too, like solar radiation and solar storms. And what that is doing also is that BZ is determining whether or not the aurora gets in or the aurora doesn't get out or doesn't get in, and then we get blocked from a show. What's BZ and BZ? Yeah, so let me think about how to explain this. I'll give you the definition. BZ is a component of the interplanetary magnetic field that is oriented either northward or southward. Kind of like when you think about a magnet, if you put two magnets together, they either attract or they repel. Or you can think about batteries too. If you put two batteries together and they're turned the wrong way, they're not going to form a connection. So what happens is BZ, it's actually the magnetic field within the solar wind. So this solar wind itself carries its own magnetic field. And that IMF, as it's called, has the BZ. The BZ is either north, like a magnet, or south. And then depending on which way it's oriented, it can connect with our magnetic field, north or south, or it can repel. What we need is we need BZ to be negative as much as possible and as far as possible in order for BZ to, that charge within the solar wind to connect with Earth's atmosphere and let the aurora flow. Now, BT is another measurement that shows the potential of the BZ to go in either direction. So I think I have a chart in here somewhere, but if you were to look at all the data on a chart, you would see that BZ is going up and down constantly, then it flattens out, then it goes above zero, it stays above zero, or it dips below zero. It's just sort of doing its own thing. BT is always sort of up here somewhere. And if BT is really high, then BZ could go really high and block the northern lights, or it could dip really low and let the northern lights in. That's sort of the potential of the BZ. So here it is on the chart. You can see, actually it's kind of hard to see probably for you, but these are a lot of the data points that we watch. And I'll start from the bottom up because the top are the most important. Here's the temperature of the solar wind as it registers on the graph. Here's the speed of the solar wind. This is really important. The higher the solar wind speed, the better our chances of northern lights. Here it's registering about 380 kilometers per second. This is how fast the solar wind is moving through space, and it's dropping lower. Those are not good numbers. We want to see that number go above 500 kilometers per second to get excited about the speed of the solar wind. The density, we also want to be really high. That's this one in orange. But density doesn't need to be very high at all in order to create good northern lights. What the density does is it includes more of those particles and charged particles within the solar wind. The more of those we have, the more potential we have for those particles to interact in this process and collide with molecules of oxygen and nitrogen in Earth's atmosphere, that is the process that emits light and create the northern lights. So when you have high density, you have a lot of these particles, little charges coming down into Earth, and then they collide with air molecules and they emit green and purple and pink. And there's a reason for that too. Each air molecule emits a different type of light at different altitudes. The phi is not super important. Not a lot of us measure that when we're predicting aurora, but at the top, you'll see the BZ in red and the BT in white. The BZ is the number we need to watch. We always want that at our latitude to be below 0. Right here, it's sort of like hovering on the line. It's not being very helpful. But that BT, that white line, is all the way at the top, up at 10 nanoteslas. So that is the potential of the BZ to go all the way to positive 10 or all the way to negative 10. If it went all the way to positive 10, we'd have what we saw for the last couple of nights, which is a lot of aurora chasers trying to see the lights and not having a lot of luck. If it went all the way to negative 10, bam, we get really powerful impact, a lot of that energy in the atmosphere, beautiful northern lights. Yeah, it's really all over the map. I would say a good number is 10. The other night we saw it go all the way up to 60. And that really packed a punch, even though that BZ was not cooperating. So this is how you can kind of see BZ. It really doesn't even stand for anything. It's just the B variable on the Z axis. And there are also these other variables that we measure, but that BZ is the important one. Other things to consider when you're chasing the northern lights. Scout out a location that works for you. Not a lot of us have dark backyards and can see them from our homes, especially if you live in this city. How many people here live in the city? How many people live in the dark countryside? A couple. Okay. And I saw one hand wobbling a little bit. So you can do a couple of things. You can try to see the northern lights from your backyard, even in the city, especially during some of these really strong geomagnetic storms. Or you can turn out a couple lights and see if that increases your view. Sometimes even one lamp or yard light outside can just obstruct your vision at night and make it harder to see the aurora. But you can also scout out a good location for viewing. So find a safe spot where you can park, where you're not breaking any laws, hopefully. Look for that during the daytime so that you know what to expect when you get there at night. We're not really encouraging people to go out and stumble over ridges and fall off ditches and land in the lake. We want you to be a little bit more careful than that. The truth is, if you go out and scout out your location during the daytime, you'll know the roads. You might be aware of issues like flooding or, a large rock in the path. You can also figure out where you want to set up your camera, the exact spot and your foreground that you want in your photograph. So scout out a location that you can later go to at night, and then you'll be in good shape. You can also look at dark sky maps or light pollution maps. How many of you have used a dark sky map? Just a couple. Okay, I'm seeing some hands. So dark sky maps will show you, and I have a graph or a slide on it. They'll show you exactly where the light is polluted and sort of gathering in the cities, exactly where you're going to see those concentrations of light that make it really hard to see the stars or the aurora. So those maps can help you find great spots near you. Also consider that you're probably not going to see the aurora through the clouds, especially if it's your first time. We really can't see aurora through clouds unless it's a very, very thin, wispy coverage that maybe has little holes in between it. Now, sometimes clouds can help you set up a really nice photograph. If you have clouds on one half of the photo, some really prominent trees, and aurora on the other half, that can make a really nice composition, especially if you break that into thirds artistically. But you can't usually see aurora through the clouds. And a lot of times when we see people saying that they could see a glow of the aurora on the clouds at our latitude, that's more likely light pollution or something from the city. In fact, we even had people up near Mackinac City that have been fooled by passing ships on their routes that have these green lights that glow at night. So you really have to kind of know about your location and what you're seeing in the sky. You also usually want to wait until about an hour after sunset, maybe a little bit longer, because sunset has its own colors, and so does twilight. If you take that first photo right after sunset, you might be capturing the green of twilight and not the green of the aurora. Remember that the forecasts are not super reliable. You can ask me exactly what the forecast is for tonight, and I can probably tell you because I read these things every day. In fact, at about 2 o'clock this afternoon, we were supposed to have a really powerful geomagnetic storm that would have brought aurora down to Iowa and Illinois. Now it's still daytime here, but that forecast didn't hit the mark because I have not seen evidence of that G-storm yet. So this is an emerging science, and it's really difficult for us to predict, and the Michigan Aurora Chasers is also really difficult for even the world's leading scientists to predict because we're putting new spacecraft and satellites up to monitor this data all the time. And so we get these forecasts and they can help you know when to be alert and when to maybe stay up late and check the data, but you probably shouldn't plan your entire life around them. The Northern Lights also has patterns. So one thing you may not know is that if you're out during a night when the aurora are really strong and you've seen an incredible show, or maybe you arrived, you knew it was happening, but you just missed it, you can wait a while because during really strong storms, especially, the aurora tends to come in waves, sort of like the ocean. So you may have missed the first wave, but if you give it about a half hour, maybe a little bit more, there may be a second wave that's even stronger and more colorful. And that wave pattern can keep happening all night long. There will be an ebb and a flow, and it'll just keep continuing. And sometimes it continues to get stronger and stronger until it finally fades. Now, safety, sleep, and sanity. These are also important. I've gotten a lot of questions this week as to when do I sleep? And the truth is, it's been hard to find the time as I'm watching the data. But when you're going out to see the Northern Lights, make sure you have a plan. Some people will set up their car for car camping. If a little caffeine can help you make that extra hour drive home, or maybe go see the Northern Lights on vacation when you have a safe place to stay, because sleep becomes really important. And we also want you to be safe. We don't want you to have to drive off down a dirt road and get stuck in the middle of the night. And maybe you have no cell phone service and all of a sudden you are sleeping by the snow. And then I mentioned sanity too, because the aurora is extremely elusive. I try to remind people we are chasing something that some people dream their entire lives of seeing just once. So we're really privileged to be able to experience this, especially if we see it all the time. But it's elusive because it's hard to predict and it's hard to find. So my number one tip is plan at least one exciting thing. I don't care if it's the first time you've had a donut in 6 months. I don't care if you buy the largest coffee you can find and it has peppermint sprinkles on top. Or maybe you take a hike at a really beautiful waterfall before sunset. Plan at least one thing you're really excited about when you're aurora chasing so that you don't have to go home empty-handed. Okay, I've been talking a lot about geomagnetic storms. The aurora is measured on the K index, which is actually over here. The K index is a scale of 0 to 9, with 0 being no aurora activity and 9 being the strongest. So we use the K index for forecast and then sometimes to talk about how far south the Northern Lights are reaching. Now, when you see this as KP, you're actually looking at a planetary average over the last 3-hour period of what K we were seeing around the world as measured at magnetometers in different locations and observatories. So that KP that you're getting in your apps is actually a 3-hour average of what just happened. It may not necessarily be talking about what's going to happen ahead. And that's really important to remember because KP tends to mislead a lot of people, especially if you're looking at an average over the past. Now, what do we need to see the aurora in Michigan? Generally, it's really good for us to get a geomagnetic storm because K1 is really low. They might see something in Alaska. Actually, they almost always do in other parts of the north. K2 is a little bit stronger, but it's still only really relevant for the polar regions. K3 is going to bring aurora down into Canada. K4 is good news for the upper peninsula of Michigan, but it's not going to bring much to the mitten, to the lower peninsula. And then once we reach K5, this is storm conditions. So those storm conditions bring much more powerful and sometimes more colorful aurora. And even if they're not colorful, you can often see these aurora move very quickly, form shapes and make formations and patterns across the sky. So a G1 storm is a K5. G2 is K6, G3 is K7, G4 is K8, and then we max out the scale with G5 at KP9. We have not seen G5 yet this year, but we did see a G4 on March 23rd, 2023, and I believe very briefly on April 23rd, 2023 as well. So these are the storm levels. At K4, you can see the aurora in the Upper Peninsula. Like I mentioned, at K5, you can see them north of the 45th parallel, which is about a line from Traverse City to Gaylord to Alpena. And then, so that's your G1 and K5. What we need to see them right here is a KP6 or a K6, and that's a G2 storm. So there is actually a G3 storm watch for tonight. I haven't seen it hit yet. I'm hoping it does, but we'll have to check all of our data and maps to find out. So this is another way that we can measure the aurora. We can also measure it in hemispheric power. This is a map that I like to use all the time, and I've added this to my website at kaelinart.com/aurora. So it's just a link on the internet that you can go to and you can refresh the page at any time. This is called the ovation model. The ovation model actually maps out what is happening with the solar wind from a satellite position just outside of Earth's atmosphere in orbit at the L1 point in outer space. So this is collecting real data, and then it's going into this map. The only thing that can maybe make this map wrong is a glitch within, all that hardware, or maybe that pesky BZ. Which again it forms that connection that we need to create a flow of northern lights into the atmosphere when BZ is negative. So these are the components of the ovation. Here's how to read it. Most of it is dates. At the top it says NOAA Space Weather Prediction Center, Aurora Forecast. Then it gives you for the date in universal coordinated time. So that's just the date written in universal time format. And this is an old one, I'm sorry, but this is a good one because you can see here, a lot of times on the ovation model, we just get a little sliver of green and it's all the way up here in like Canada or the Northwestern territories. But when it starts to turn yellow or starts to turn red, that signals a high probability of aurora. And that means get outside, especially if it's nighttime. So it's simpler than it looks. At the top left is the name, the forecast, and the date of the forecast. At the top right, this is where the important stuff is. It's giving you a forecast lead time, 42 minutes. I guess I have a pointer here I could use. So it's saying in about 42 minutes, we're going to get a hemispheric power index of 104.3 gigawatts of hemispheric power. Now, 104, that's a lot of gigawatts. And the range is supposedly only supposed to go from 5 to 200. So once we get into 100, we're getting close to that high end of the range. Now, we actually saw this go above this range this year when we were watching ovation model during some of these really strong storms. So it can go even higher. But watch that hemispheric power. If you can pull this up on your phone or you can see it in your apps, but in your apps, it might be a video and only the last second is going to show you this forecast of the future. If you notice in the UTC dates on your app, the other portion of that little video is going to be the past. And then the very last second is the future. So watch this number. If it's going up, that means it's getting stronger and the aurora is coming farther south. If it's going down, that means it's not looking too good. And if it's jumping all over the place, well, it's anyone's guess, and we might get lucky tonight.
Don't watch the video.
Yeah, it is misleading to watch the video. So here are a few of my photos of northern lights of Michigan, and it's so bright in here you can't really see them, but that's me under the trees in the Upper Peninsula. We caught an all-night show there on the spring equinox. Remember your equinoxes of 2021. And then this was also taken in the Upper Peninsula, and there I am again. on these chases. These are some photos I got from Alaska, much more brilliant. But also these were taken on the iPhone 14, which has come leaps and bounds in low light photography. All you need to take Aurora photos on an iPhone 14 is a tripod or something really steady to set it on, put it on night mode, move it to the max exposure time of 30 seconds. Bam, beautiful photographs. In fact, the cover of my book was taken on my iPhone 14. So chasing the Aurora in Michigan, there are a few more things to know. The KP always looks the same on the KP map. This shows you where the numbers register. So you need a 3 to see it all the way up here, a 5, again, to see it in northern Michigan. And these lines are going to tell you when the Aurora is overhead, supposedly. Now, it may be different because Aurora can be regional and it can be different in different parts of the world. In fact, if you look at the satellite view a night after the Aurora, you'll see like wisp and clouds and swirls here, and then like a little dip there. And so it sort of goes all over. But you can see the Aurora overhead in Mackinac City at a K5. And then in the middle, you would need a K6 to see it overhead, but that'd be visible from low on our northern horizon. A K7 is going to bring it down into the states below us, and then K8 and K9 push it on down closer to Cuba throughout the US. So here's our parallels mapped out. Again, you can see a little bit closer that K5 is going to come overhead at the tip of Michigan. You can see a K5 from the 44th parallel here, which would be the thumb. So they would get lucky during a G1 storm. And then we really need K6 to start seeing it in the sky overhead in the southern part of Michigan. Figuring out what parallel you live near can help you figure out when to know when to watch for northern lights. Because the 45th parallel is sort of this magical line where we get a lot of G1 storms coming overhead. For some reason, when you're that far north, and there are a lot of legends about the 45th parallel, you start to see some really magical things. But if you live at a different parallel, just know how far south it is so that you can watch those warnings and alerts and see when Aurora is coming near you. These are dark sky maps. This is going to tell you, okay, Ann Arbor's down here somewhere. Unfortunately, it's really red and orange and yellow where we live. That is light pollution that is blocking our view of the northern lights. You all know what this is, right? Anyone want to shout it out? What's this big blob? Detroit, you know, and Chicago is even bigger. Poor Chicago. But if you can get north of these cities, you can have a pretty good view. Now, the one thing to watch out for is if you were to say go north, I think this is like Chelsea area, maybe. If you were to come over here and look north, you'd be looking straight at the light pollution of Lansing because that's going to be directly to your north. But if you can find a view where you don't have directly north of you some of those light pollution centers, you'll have a better chance of seeing the northern lights. All right, the Space Weather Prediction Center is the trusted national agency for our Aurora forecast. So they issue the Aurora forecast. You can go right to their website, just look up space weather in the US, you'll probably find it. And you can get these, you can get these forecasts sent right to your email inbox. Now, this is telling you that it's a 3-day forecast because the time it takes from for that solar activity to fire off the surface of the sun and reach Earth, the light travels at the speed of the light, but the wind, the solar plasma, it takes about 3 days to reach us. So we can only really know the Aurora forecast about 3 days in advance. But they will issue these, I'm sorry, I keep pressing the wrong button here. They will issue these forecasts that tell you, okay, on May 11th, and they're issuing these in universal time, we have the possibility of seeing a KP3, a KP2, KP1, and a G3 storm. Now, this was issued for May 11th in universal time. That actually translates to our evening. And then we're also expecting to see G1 storms at K4 rounding up to K5 and G2 storms at K5 rounding up to K6 and more G1 storms all night long. So this is actually what we're hoping will play out tonight. But we have to watch for that impact and make sure that that solar wind gets into our atmosphere in order to create those northern lights. They also give a rationale at the bottom here. So they're saying the arrival of the anticipated CME, this was a solar flare that released from the sun's surface and fired toward the Earth, later on the 11th of May and early 12th of May will likely lead to G1 through G3 storms, and unsettled to active levels are expected on the 13th of May as the CME continues to wane. So keep an eye on the sky tonight, and if it doesn't work out, keep an eye on the sky tomorrow night because we have a chance. Yeah. Mhm. Yeah, so you actually have to, so not only do you have to think in terms of military time, like 100, 100 or whatever. Sorry, I'm not a military time user very often, but you also have to convert for our time zone. So what's going to happen right now during daylight saving times is you're going to subtract 4 hours. So I always kind of like default to midnight. Okay, what's happening at midnight? Well, subtract 4 hours from that. That's going to be our 8 p.m. So let's see. 7, 6, 5. So from 5 to 8 p.m. tonight, they're expecting this G3 storm. But it's still light. So that when that happens, that means that aurora is going to hit on the other side of the globe because the auroral oval rotates around with nighttime, which you can kind of see the slice through the middle of this thing. The auroral oval rotates around. It actually rises and it sets just like the sun and the moon. So yeah, we thought that G3 storm was going to hit during daylight, but it hasn't hit yet. So we got to keep watching. What questions do you guys have so far? You're all just kind of mulling it over. I just checked my app and we still have no signs of impact. So
Possible, it's just gone. I mean, it's there, but
it is possible for these solar wind events to kind of change direction in outer space and head a different direction. I mean, think about if they hit a meteor shower, that might just kind of ruffle their feathers and make them disappear. So when I did that glance, I went to the ovation model because I always have it pulled up on my phone. I have this website right on my phone in my browser. All you have to do is hit refresh. That's what I do. I hit refresh and I see it. And yeah, I won't do it because it's on a different page now. But then I'll look and I can only see a little tiny green sliver. Yes, in the back. I have a lot of materials on my website, and this will be available on YouTube after today too. Yeah, from the library. In fact, I think they're live streaming right now. So yeah, so we talked about aurora chasing in Michigan. Know your latitude, know what KP you need at your latitude. There you are with the latitudes and the 45th parallel. Here you are with night pollution. And obviously, the more in the country you are, the darker your skies are going to be. So the Michigan Aurora Chasers, I have a few slides from us because every time we have a really fantastic, successful night, I try to capture a few of those photos and share them. There are actually many different kinds of aurora out there. You can see pillars, you can see blobs, you can see a new formation that's called the dunes. It's like a little ripple that goes through the northern lights in the background. You can also see Steve in the picket fence. This is Steve in the picket fence up there in the corner. It's a really stripy thing that actually appears in a separate portion of the sky. So if you're ever out looking for Steve, he has an incredible name with an incredible story behind it. Watch the aurora, then turn a little bit to your left if you're looking north, because it'll appear a little bit more in the southwest portion of the sky. We've been featured on the Weather Channel and the Washington Post, and people love following our live chases. Every now and then we'll hold a live chase where we are pretty confident that we can lead a group of people out to see the northern lights. Woo, how much I would love to do that tonight. But I am not seeing impact of that geomagnetic storm. So there's a few more of our photos. And you're welcome to join us. We're a Facebook group open to anyone. And like I said, we try to hold events all year long. Here is my book, Below the 45th Parallel. It gives you the tips you need as a beginning aurora chaser to try to spot those northern lights, some of the obstacles you're going to face, a breakdown on the numbers, where to go for those maps, all the information that you need to get started is in there. And I have some more upcoming events coming up. I'm doing a lot of talks this year. The book has been really popular and it's sold in international dark sky parks in Michigan, as well as many other places. So I'm really thankful for the support. And I hope to see you guys out there at some of these star parties and maybe the annual Aurora Summit, which I co-founded in 2017. At the Aurora Summit, we celebrate the art, culture, science, and photography of the Northern Lights. And it's a weekend-long event that's a lot of fun. So that is all I have. Thank you so much. And I'm happy to take questions. I see one in the back. Let me start all the way in the back with the glasses on your on your head. Yeah, that's a really great question. So the question was, sometimes we don't expect anything to happen and all of a sudden we weren't even paying attention, something amazing happens and it seems like there's no explanation. Is that because we just weren't seeing a CME on the sun? There could be a lot of reasons for that. Actually, the peak season for aurora chasing, you can see them any time of year in Michigan. We're really lucky to have dark summers at night. But the peak season is from the about the fall equinox to the spring equinox. So about September to April. And it's actually September to April, but the equinoxes are a powerful spot. And part of the reason that's the peak season is because that pesky BZ, that orientation of the interplanetary magnetic field works in our favor during the winter and the fall and early in the spring. So that BZ is more cooperative and it's a little bit easier for the solar wind and the northern lights to create that connection with Earth where they funnel in. During the summer, it's much harder. Now, the surprise events could be anything. We actually have solar wind happening in outer space all the time, but usually it's just sort of like a low hum. That's an analogy. It's not a technical term. But usually it's just kind of like a low hum and sometimes it picks up speed and we may not exactly know why, but it's always out there. There's always the potential. Now, the other thing that can create a surprise show is if that BZ totally flips southward or negative without warning, that's really all we need to get some really powerful aurora. And to me, that part of it is a little bit like magic because it's extremely hard to predict. Another question? Yeah, in the pink. Mm-hmm. Yeah, so when the BZ is turned northward, it's actually blocking that connection to let solar wind flow into Earth's atmosphere. And, you know, the solar wind is a lot of things. The sun creates radiation, it has electrical particles. Actually, when we do get aurora, it has implications for our infrastructure because that's the type of electromagnetic energy that can cause power grids to collapse. It can cause satellite GPS to malfunction. There was actually a launch by SpaceX where they launched Starlink satellites into outer space. And there was such a strong aurora, yeah, I guess you could call it an aurora storm, technically a geomagnetic storm, that it knocked most of those satellites back down to Earth because it shook them so hard. So there are implications and most of them don't affect us in real life unless we were to lose power. There's been times when Sweden lost power across the country for an hour, or Canada had to put some extra backup behind their power grid, but most of the time we don't really notice it. Another question.
Does it affect all of a sudden that drops really negative?
Yeah. Yeah, so if that BZ drops really, really far south, that kind of clears the way for all that power to come through. And the K index is a measure of the strength of the aurora or the power of the aurora. It's one of the many measures, but the KP can absolutely go higher when the BZ is really far south.
You see that on the elevation monitor?
You will, yep, and it'll come through and you'll start seeing red on the map as we get storm conditions.
There's also a line in the elevation map that is, it shows viewing area.
Yep.
One single black line further down.
Yeah. I've never really tested out the viewing area that strongly, but what that line indicates is you should be able to see the aurora low on the horizon from that spot. So that would be the cutoff. Anywhere farther south of that, you're not going to see aurora according to the viewing line. Yeah, another question from the lady next to you.
When you said you can see it through the camera, if you have a blurring camera, can you see it? Or do you have to actually take a photo and then?
Most of the time you have to take a photo and confirm, but actually it depends on your camera. If you have a digital kind of sensor, my iPhone is actually able to pick up some of the things I'm not able to see before I snap the photo. So, yeah.
Website or whatever to get that ovation model.
It's very long. It's like services.noaa.swpt. I don't know. I'll give it to you. So if you go to my website at kaelinart.com/aurora, I put it right on top. Yeah. Yep. This man here. Did you get the video version or did you get the still version? Because what you really want is that still image. Yeah, you really want that still image, but I can share that link with folks, and it's I'll read it out loud for you here. I don't know if you'll be able to get it all. While I pull it up, do we have another question? Yeah, right here. Yeah. Well, it would have hit during daylight, so we wouldn't have seen anything because the aurora is happening in a different part of the world when we are in our daytime. By the time we get to nighttime, the aurora starts happening here. It's possible to catch aurora right as the sun is setting. In fact, I know a lot of photographers who have captured sunset and aurora in the same photograph. But often that's not very visible with your eye. So yeah, and I'm not on the right link here. Yeah, but then it has a /images. So the website is services.swpt.noaa.gov/aurora-forecast-northern-hemisphere.jpg. If you go to my website, kaelinart.com/aurora, it's there. Yeah, another question in the back.
But it would need the earth facing the sun, like so where the sun is.
Yeah.
Or electromagnetic, like more energy. So this is like the opposite. So the fact that it's like
So yeah, so the ovation model, she's saying it looks a little confusing because you would think if it were facing the sun, then you would be seeing more coming in. What you're actually looking at is the North Pole right in the center here, because the aurora filters in through the North Pole and the South Pole. And they have an ovation model for the South Pole. I just never use it because I don't live in New Zealand or Australia. But you're not going to see more of that activity from the sun. What they're actually trying to measure here is not how much sunlight is hitting or how many particles are hitting. They're trying to measure how many of those are coming in through the North Pole, creating that process which emits northern lights, and emits purple, from nitrogen, and green from oxygen, and pink, from hydrogen. They're trying to measure that and see how far is that activity pushing down into these regions, and then how high is that probability that you're going to see some of that activity near you. So it's really a map of the earth from above, and nighttime is up there on that half. Here's the line of night, and so it's rotating around the globe. Daytime is on this side and this one, and then nighttime begins here and it rotates around the globe. Or I'm sorry, yeah, no, that's daytime. This is nighttime because the strongest aurora is happening at night, and then you just watch it rotate and come to different parts of the world. Does that help?
That makes it so that the energy is staying in the nighttime area, or is it just like
No, it's just the auroral oval, actually, it rises and sets just like the sun. So when it sets, it'll be on the other side of the globe usually. This one is so strong that you could see it maybe at twilight or sunrise or sunset on those margin areas, but really it rotates. So, all right, I think we want to leave a little bit of time for books. So I'll turn
Yes,
it
yeah,
over.
sorry, I'm sure she can answer a few questions while you're.
Absolutely.
But thank you, Melissa. Thank you so much.